Good morning! This is Mini Geology. Here we are in beautiful Montrose neighborhood in Houston, Texas. This is Daniel Minizini, and good morning to everybody in Houston, Texas, and around the globe, including those astronauts that are spinning around our planet in the International Space Station. So today we are going to talk about continuous learning. Continuous learning, these last days we had the coming out day, especially dedicated for the LGBTQ groups, and I learned a lot. I participated to some of the meetings that they created nationwide, and actually it's an international day of coming out, and I sat with them and I learned about the tough times of our brothers and sisters belonging to LGTB+, especially in their place of work. So geo minorities of all kinds, write me at minigeology@gmail.com. Write me and come out. Not necessarily being part of the LGBTQ, but also all other sorts of minority. We want you here at KPFT in Houston, the HD3 channel. We want you to hear your voices. We want you to be part of this journey of mini geology. And I personally, I really like to continue to learn. So I would like to do this through showing you, actually putting you in a right, comfortable, good position to listen to some of these video interviews that I made time ago. I create kind of a patchwork and short clips for you where some of these amazing geologists or geoscientists in general, they give you suggestions. They talk wise words. And I think that these wise words could be useful for all of you. Either if you're a student, either if you are a professional, even if you have a PhD and you are a CEO. So having here, the first one for you is of Professor Hugh Jenkins. He's professor at the University of Oxford in UK. I met him in the outcrops of the Cretaceous in Italy. And I asked him these questions in here. Hugh, can you describe your best student?
My best student? Well, the best students in general are those that have lots of ideas themselves, which may challenge your own ideas, which may prove you wrong, which is fine, but obviously, you know, they need to be independently minded, they need to be careful if they're working in the laboratory, and they need to be creative. So they need a whole raft of talents, but I think to question and challenge those are really the key properties, the key attributes that any good student must have.
So that was Professor Hugh Jenkins talking mainly about the best students, but questioning our professors or line managers or the writers of the books that we read. They could be practiced anywhere by anyone. Now I have a very short clip about Professor Emiliano Muti, one of the characters that they spend years and years in the outcrop mapping by foot, on top of a mule, on a horse, moving by boat or ships from one island to the other one in the Mediterranean. He's a strong character, and he has been contributing to the understanding of the sedimentary processes. Here is where I interview him in a rainy day at a conference in Milan, also in Italy. Let's say I'm a PhD student and who wants to remain in academia. What's the way to go and remain in academia?
Oh, that's very simple. Be patient, read a lot, do a lot of good work, and have the chance to find a good professor.
I like that. Is be patient, read a lot, which means also read the rocks a lot, so map, and find a good professor, a good mentor, a good advisor that follows you. This is also something that we can continuously do every day of our life in whatever profession we have. Let's see in here. We have Bob Falk. Bob Falk is professor at UT in Austin, and all geologists, they study the classification of carbonates that have his own name, the Falk classification. Well, his man is alive, is old, yes, but is still full of energy. And Bob Falk opened the door to me when I went to knock at his door. He didn't know me at all. And the very first thing, he showed me some of his pictures around the war, and I had to guess. The very first picture he showed me was like a balcony with flowers, and I don't know, I had to understand where was that balcony with flowers. Obviously I couldn't. But anyhow, that was in Rome, I think, and he was really, and he is in love with Italy. I don't know what's going on with this geologist in love with Italy. He was so much in love with Italy that once he discovered that thanks to his classification, his name was so well known, he said, well, I should propose a project to go where I really like. And I think that he proposed to go to Rome, to downtown Rome, to in front of the St. Peter's Church in the Vatican City, and study the carbonates of the columns made by Bernini, il colonnato del Bernini. So here are a few words from Bob Falk. Would you like to say anything to students that are coming out from earth science and they are looking for a future in earth science?
Yeah, I would say that don't be afraid to follow radical concepts, even if your professors say you're nuts or something like that. Have the courage to follow up your own discoveries.
Okay, thank you very, very much, Bob. So, follow your thoughts. If you're really convinced about what you say, if you have the data that support your ideas, if you feel strong, but you think you're crazy, don't bother. Just move on and let the others say that you are crazy, that you are cuckoo. You are convinced, you have the data, you have support. Go ahead. I remember then once drinking some beers with Brad Sageman, another professor. He says that it is not what you know, it is who you know as far as you know enough. I really, really like this. It is a mix in between the Italian style and the American style. Brad, he devoted most of his career to study the western interior basin of North America. In particular, the relationship between rocks and time. And he is so funny, and he enjoys so much play his guitar. Let's listen to him. any suggestion to a potential student or researcher that wants to continue doing research in earth science? What would you suggest to him?
The most important thing is to be passionate about what you do and to give it your all.
Is enough passion?
I was telling Steve last night that I was describing the story of how I got a job at Northwestern, and I said it fits that old dictum of it's not what you know, it's who you know, because you heard just earlier tonight about a little bit of the history at Northwestern. A man named Cy Schlanger was at Northwestern, and Schlanger was a colleague of Mike Arthur's. He had been Mike Arthur's master's advisor. When Schlanger died, the department offered Mike Arthur a job. And Arthur, who I had gotten to know through my thesis advisor, had invited me to come for a postdoc. At the time he was contacted by Northwestern, he had already accepted the position as chair of the department at Penn State. So he said to them, "I'm sorry I can't accept your offer, but you should call this kid Sageman, who's finishing his work in Boulder, Colorado." So the phone rang and they asked me to come interview. It's not what you know, it's who you know, as long as you know enough. There's a fundamental, you've got to be in the game, and then who you know is important. So it's important to make connections within the field.
Thank you very much, Brad.
Sure.
See you, enjoy. Great. That I really enjoy that. Yeah, it's a little bit about that, I think, as well. I'm here because I was volunteering, and I'm volunteering in the prison show, which goes live every Friday from 9 to 11. And so they knew I was a geologist. Actually, I joined them because one of the members of the gang of the prison show is a geologist. And so because they knew I was a young, passionate geologist, they said, well, here you have a new medium for you. Microphone, headphones, radio waves. Go ahead. So it is a little bit like Brad says. Now I would like to play something with Gary Parker. Gary Parker is a professor at the University of Illinois, and he uses fluid mechanics and applied mathematics to treat interesting geomorphological problems. He received multiple awards, a lot of them, and I think that Gary is a visionary. This interview was made a long time ago by my good friend Alessandro. And here we go.
What would you say to a young student?
I think the very first thing such a person has to ask is, do they want to go into a research-oriented career? Because it turns out they're smart and capable and have done well in college, and it seems like a respectable thing to do. Or do they want to go into it because as they work on various problems as an undergraduate course, they've gotten really enthusiastic and passionate and curious. And if the second part is not a substantial part of their answer to those questions, then there are plenty of interesting jobs available for very capable people that don't have the kind of pressures of the research world. So ask yourself about your inner level of passion.
Okay. Ask yourself your inner level of passion. You too now. Ask yourself. If you have it, well, you have a long way to go. And you can really research, and in the broad sense of the word, research whatever is the topic you love, whatever is the topic you are passionate about. Ask yourself your inner level of passion. Gary, in this video, the background noise is about a trolley that he's dragging around, and he was being interviewed while he was strolling on campus. Claudine Cohen. Claudine, I'm very glad to have this video because Claudine is one of the few women that I video interview. There are not those many. Actually, I will really catch up with the Association of Women for Geoscience and talk with them about the issue that we have, the so-called gender issue. We definitely need to develop that much, and I need to learn from them. So again, this is about continuous learning. So AWG, Association of Women of Geoscientists, if you are listening, write me at Geology, MINI Geology, at gmail.com. You will find all of these videos in minigeology.com. So you can go and play them and see also the video of these audio clips that I'm playing right now. So Claudine Cohen, I was talking about her because he's a philosopher and historian of science. And she is director of the École des Hautes Études in Social Sciences in Paris. Sorry, my miserable French. So Claudine has been a visiting scientist in Princeton, MIT, New York Public Library, the Getty Research Institute, and so on and so forth. So another of these great geoscientists, even if in this case is more a philosopher and historian, but related to geoscience, that is talking here for you, that you're listening right now. And this is what she says. She says to try to experiment different methods in your learning, in your research. This is her voice while I was sitting on a bench with a breeze close to the Pacific Ocean in California. I think it was close to Carmel, well, not far away from Santa Cruz. Here we go. What would you suggest to a geologist that would like to approach the history of science?
Well, I think it's a very good thing, but I think he should perhaps at first read a little what has been published, especially in the last 30 years. There's a huge bibliography, which is very strong and interesting. I think people have done a wonderful work trying to understand new methods, experimenting new approaches of the history of geology. Someone like Martin Woodward, for example, he's my hero. He's done wonderful work, and he's a geologist by training, but every time in every book he wrote, he changed methodology, and he experimented new methods. And I think this is very admirable, because people generally stick to a method and they don't change. But he was like someone in the lab, and trying to experiment. And I think someone who wants to be a historian, you don't improvise yourself, a historian. Even if you have a historical sensibility, you have first to learn from what has been published about the possible methods, and then make your own vision of things.
Thank you very, very much, Claudine. Right. Yeah, and talking about those methods, I remember changing methods myself for my studies. I am a sedimentologist, and at the very beginning I studied through the tools used in the study of modern systems. So I was really studying the seafloor and the coupling of the water column and the sediments. So I spent a couple of years all together with different campaigns offshore, sometimes 30 days long, sometimes a couple of weeks long, And that was the very first method, approaching the modern systems. It was not really geology, it was modern geology, studying the Holocene. We don't really have rocks, we have sediments. And then I was forced to change because I left the academia to go to the industry, and there I had this new method of seismic interpretation. So I was looking at the sea floor that was already buried, and it created reflectors under the actual and present day sea floor. And then I moved again, and then I went to study the old rocks, the ancient systems, at the beginning through the cores of the rocks that they were in the subsurface, 1 or 2 or 3 kilometers under our feet. And then what I did was I went and I tried to study the experiments. So going to the fluid tanks, being visitor scientist in some universities. I remember one in Bloomington, Indiana, and trying to experiment myself and reproducing nature. So deciding what kind of water I wanted, cold, hot, hypersaline, zero salt. I want to dump clay or sand. That was very nice to control nature, some of its parameters. And then also I went to the outcrop. I remember I was doing a project with seismic, and it was not enough, the resolution, so I proposed to change method, and I said, yeah, let me go to the outcrop. Man, they say yes. This is one of the most beautiful things for a geologist, to go to the outcrop. Actually, I just came back last week, and I took 22 geologists with me to show them the area that I was studying in southwest Texas. And I was pretty comfortable in that area. I've been studying it for 3 or 4 years, and I have all sorts of samples, analysis. But man, I was still learning. I was learning how from these people that were coming with me for the very first time in the outcrop. And so that's about today. Continuous learning. Let's see, in here I have something now about Victor Baker, which I interviewed the same day that I met Claudine Cohen, that you listened a few minutes ago. Victor Baker, he's a former president of the GSA, the Geological Society of America, and he metamorphosized from being a geologist into a historian. Anyhow, he's one that likes to build bridges between public policy, the environment, and philosophy of science. Here we go. Would you like to suggest anything to the researchers that they're doing their own research, maybe in a very specific field, from the philosophical point of view? Would you like them to suggest?
Well,
I
think from a philosophical point of view, we have to recognize that these various systems that we think as people are how to do things are greatly inferior to what nature has to tell us. And nature can tell us things. We have to be open to it. It may be the thing that provides the answer of what we should do. I think this is the reason why I could never decide what kind of geology I wanted to do, because I always kept getting things from nature suggesting that I do something different. Like the story I told about the planetary science. And what I found is that's a very rewarding way to look at things. You don't know that it's going to turn out, but it does turn out. And if you trust it, you find out things that you didn't know before.
Thank you very much, Vic.
Okay.
Yes, I think that it is important sometimes to go back to the philosophy, which is at the core of the essence of mankind in our societies. Just think about the topic of happiness or democracy. Both of them started and started and started again and again by this that we call today philosophers. They didn't call themselves philosophers at that time, but there are specific people in the intelligentsia of the past that they went through these very important topics that we almost give for granted today. If we go back to those authors, we can see differently the things that we do every day, not only the research that we do or the duty that we have to do every day in our profession. Just go back to your book of philosophy of high school, if you have one, or just buy one that just tells you about the basics. Go back, read. Okay, you don't have to go as back as the Greek, the old Greek philosophers, but maybe Kant, Hegel. Start from there. They are modern enough that our society is still shaped by their thoughts. The next one that I want to play, the next clip, is with Henry Possamentier. He has been a protagonist in the development of sequence stratigraphy and seismic geomorphology. And here I met him at his home.
I don't know how most people do it, but I never had a plan for my career. I always felt like I wanted to do, whatever I was doing, I wanted to do it well, and the career would build itself. Because when you find something you like, you typically do it well, or at least you have a real passion for it. And if you have a passion for it, you'll do it well, and it'll be recognized as such. And I've often told the young folks in the office that it's critical. You know, we're all salesmen in what we do. We're all selling products. We're selling ideas. We're selling prospects. We're selling something, and it behooves them to come up with the most striking images that you can get to make your point. And when we look at technical papers, typically the first thing we do is we look at the figures, and then maybe if the figures are interesting, we might read the text. But the figures have to speak for themselves. And to get good figures is a talent. It's a skill that can be learned, but it's definitely a skill where you don't want to make them too complicated, but you want to make them compelling. And that's where artistic talent really pays off. One of the most valuable courses I have taken in my entire career, it's not sedimentology or stratigraphy, this and this, not book cliffs, field trips, and blah, blah, blah. No, the most influential course that I have taken was effective communication skills. In my early years with Exxon, they put us all into this course. It was a 2-day course on effective communication, and the basics that they taught in that class, I still refer to. It's a very simple process. It applies to any presentation you give. It applies to any paper you write. It applies to every paragraph you write. And specifically, after you've established who your audience is, I mean that's always you need to do. But you always start off by giving the news. Think about your audience. What's the news? What's the key takeaway for the audience? And then, what's the news? Why is it important? So this is my news. This is why it's important, this is how I know it, and this is what I'm going to do about it. If those 4 steps, if you follow that in a paragraph, in a PowerPoint presentation, in a written communication, that has made such a difference in my ability to communicate ideas.
Well, that was Henry Possamentier, and I really agree with this very last part on trying to organize your thoughts, which is useful for a scientific paper, a presentation, even the radio in here. And I'm going to remind them for you. So one is, what's the news? What's new about the things that I'm telling you? And so why you should listen to me while you're here. Second is explaining the importance of the things that you are going to say. And so you raise attention even more. The third part is explaining how I know these important things that I'm going to tell you. Does it derive from data, from experience? How do you know it? And then finally, how I apply it. Why is it useful? This thing that is new, that I tell you is important, and I explain you how I know it, how am I going to apply it to the world, to the society, to my thesis, to whatever. But I don't agree that much when he says that we are all salesmen. I don't agree with that idea. Maybe he wanted to use a synonym of salesman, and also the idea of using images to catch your attention. How should I do it in here in the radio? The radio is a different medium, and the importance of the radio is that you don't have to use your eyes. You can do other things while you are listening to us now, and therefore you have a different kind of imagination. You can use it, I don't say more or less, but differently. Maybe you can think a little bit more. And now, here are some words from Roger Slatt. And I think that he is going to tell you how to find a good job in oil and gas business. Roger has written and edited, I think, 6 books on petroleum geology. Now he's a professor at the University of Oklahoma. Here we go, Roger. Questions for the students that they are finishing their studies and starting their career.
As I said, I've graduated over 60 graduate students since I've been at Oklahoma, and they all come in and ask me questions. What do you think? I tell them you'll have a good career in the oil industry. I loved it myself when I was there, and most of my students get multiple job offers, and they're all climbing the ladder quite quickly now. Those that have graduated, I keep track of them, and so I encourage them to go into the petroleum industry. I'd say of those 60 or so, maybe only 2 or 3, 4, I guess, have had gone on for PhDs. And one thing that I'm very much different than most professors is that I don't try to clone myself like many professors do. I don't want, my students should be better than me when they get out, and most of them are. So that's the way, those are the sort of things that I tell students.
And that was Roger Slatt. I think I met him in one of these halls during a conference. And Janak Bhattacharya, he says, dive directly into the problem, even if you don't know anything about it. Janak investigates the sequence stratigraphy and the 3-dimensional phases architectures. So he is well recognized in the international community. Here we go. What do you say, Janak? Any simple suggestion to the students? Let's say that you talk with your students. Do you give them any simple suggestion about how to approach science, how to approach what they are doing for their master or PhDs?
I don't particularly. They take the classes, they get the background. I kind of like to throw them in the field, collect some data, get their hands a bit dirty. I really think, unless you're an experimental scientist, if you're an outcrop geologist, it's kind of interesting. This semester, I had a student who was too sick to go in the field over spring break, whereas my 2 other master students, so we all went out. And at the end of the semester, it's clear that the students had gone out in the field, even for a week. All of a sudden, they had a very immediate idea of what it is they were supposed to do. Whereas a student that didn't go in the field, it was still theoretical. She just didn't have a feeling for what the rocks really looked like, and so when she defended her proposal, it was weak as a result. It was too bad she got sick. So my advice is get the students out working on the problem before they even know what the problem is. Kind of like playing drums. Like a famous drummer by a band I know named Carl Farmer talked about how to play the drums, and he says you're better off sort of just sitting in a drum set and learning a beat, rather than just holding a pair of sticks and learning the snare drum. If you want to play drums, it's all about the instrument accompanying music, not about a snare drum learning a Radha-McHugh or a paradiddle, right? And so in geology, I like to sort of get the students to jump in the deep end and get the holistic view of what the problem is, and then sort of narrow it to eventually write a tight and hypothesis-driven proposal. But, and the only reason I get away with not doing that is I've got, 30 years of experience. So, I already know what the problems are on the side. So I know if I look at an outcrop, I'm going to kind of see the hypotheses are going to present themselves very quickly. That's not true for students. They have to learn that process. But, you have to learn by doing, right? You can't tell someone to do it. You have to get them out in the field, get them out looking at things, teach them how to identify rocks. And until they get comfortable identifying things, only then can they start to see where the anomalies are that then invite them to ask the question that hasn't been asked before.
Janak, is more about passion or is more about ambition for you?
Well, it's more about the passion, always.
Cheers. Yeah, here we go. You listen to that clink because we were drinking some beers. And this is the beauty of all geologists, all the people that I met. Not that I drank with all of them, but they were ready to do it. And in a metaphoric way also. So they were open arms, always talking with me, welcoming me. And that means also welcoming you, because when I talk with them, I tell them this is going to be uploaded. It's going to go to this minigeology.com, which is a YouTube channel. And the entire geological society, the great community, is gonna enjoy your mindset, the way in which you tackle the problems in your profession, in your life. And now I have something from Professor Basu, the eclectic Professor Basu that studies the provenance of the sediments from the Earth, from the Moon, from Mars, in the meteorites. And Professor Basu, what do you want to tell us? Let's see. Anything that you want to suggest to students that they are like pursuing like a career, looking for a job for the first time?
Try to disobey your professor. And in my teaching, if I may add one thing, when I used to teach sedimentary petrology here, sandstone petrology here, the kind of sandstone petrology has changed. But anyway, when I used to teach, my first assignment to graduate students in that graduate course was to give one of my papers for them to read and to answer only one question. Find one error in this paper. There are several I know now, but find what's a mistake.
Very good. Thank you very much, Professor Basu.
You're very welcome.
Yeah, I know that feeling of being conscious that you wrote something that is wrong right now. And actually, I'm still learning and continuously learning how to write. Really is like I'm in labor whenever I have to try to write a paper. And Professor Basu is telling you to disobey your professor. Remember, Bob Falk was telling us to be crazy about your ideas. Don't bother about the other ones. And this is Ron Steele. He is professor in Austin, and he is Mr. Clinoforms. Here, Ron Steele studies the sediments, and I think that he says, "Man, the boss." Not the boss, the boss. Sorry. What would you suggest to students that are coming out from university?
Oh, I have some interesting advice.
From my industry experience and some other experience, I always warn them, be careful who your boss is. If you don't get on with your boss, you're wasting your time. You need to find another boss. If you don't have good chemistry with your boss, you're completely wasting your time. It doesn't work.
Yep. Doesn't work. Doesn't work. So, change boss, not boss. What about Paul Potter? Paul Potter, he criticized the academic model of a career for a research geologist. And instead, he emphasizes the importance of having practical interests and industrial experience before teaching. Paul, are you here with us?
I would say one thing that was important, neither Wayne nor I were typical professors because we didn't go to school and then teach school. I think that's the key. We came to teaching after industrial experience, and I've always promoted that. I think that's so much better than getting a PhD, getting a doctor's degree, and then getting an academic job. I don't think that's good for a career and is not good for a country.
Do you think that it is still the same today?
No, the academic model is get a PhD, get a postdoc, and then get a teaching job. That's what universities like, and that's what the Science Foundation pays you to do, you see? Science Foundation will pay for the postdoc most of the time, and the Science Foundation, which wants publications. Whereas if you do this other thing, you probably won't get a top-flight teaching job, even if you want one when you're 40, because you don't have enough papers, you see. But what you have is a real insight to the practical world. You know, that's not a very popular idea to have around universities, so I'm never too popular when I talk about that.
Do you want to say anything to students that are approaching new research or new topics in the earth science?
I've never thought about that. What I would just say are two things, and this is people in several roles of life have told me this, and I think it's true. I haven't followed this too much now, but if you're still in school, you should be prepared to work in fields that you not know too much about. In other words, don't expect to do the same thing in life all the time. Well, if that's a reasonable future, if that's a reasonable expectation, take courses that don't make you too specialized. Now that's again, the modern trend is to become a specialist to get a job. But in reality, if you're a generalist, you might see a lot of things and be a lot more attractive to people to put you to work if you seem to have the capacity to do different things, not just be a SEM person, an isotope person, a hydraulics person, a micropaleontologist. So be prepared to adapt, and if that's the future, then you'd better take some courses outside of geology, or at least in different kinds of geology.
And that was the longest interview. Paul Porter, calm but precise. And this is the last one. This is Professor England at the University of Oxford. 10 seconds, the last suggestion.
Is there anything that you want to suggest to young researchers? Or
I don't want to offer advice to the young. When I was young, I didn't listen to advice from people my age, and perhaps I was right not to.
That's it, you see? So you don't listen to...
Do you know what the...
You don't listen to the advice of others. That's another advice. And that's all for today. I'm going to leave you. Remind you that we are a KPFT Houston HD3 channel, high definition. This is Mini Geology radio show. You can write me at minigeology@gmail.com, and you can visit the website minigeology.com. You'll find all of these interviews that I put in today for you. So let's continue learning. See you, everybody. Bye.